Hi everyone, this is Kona, and I'm going to go through the Chapter 1 notes. So we're going to start with types of statistics. So both descriptive and inferential statistics rely on the same set of data. So in general, our type of statistics are descriptive and inferential. The important thing here is that they both rely on the same set of data. So if you have a set of numbers, so let's say I did a survey of our class, our Math 113 class. I could do both descriptive and inferential statistics with the data from that survey. Now, the difference is that descriptive statistics rely solely on this set of data. So I can find a mean, median, mode, the range, quartiles, all of that information about this data. The difference is that's just descriptive, so just about that set of data. Inferential statistics is where I could take that data and then do different tests or do different things that you'll learn about in the future, different statistical tests, to make generalizations or guesses about a larger population. So basically, I would take that set of data from our Math 113 class, and then, for example, maybe I would make generalizations about all Math 113 classes here at Richland, or maybe make generalizations about all evening college students or all students who take hybrid classes or online classes or something like that, depending on what your population was. So inferential statistics take that one set of data and make generalizations about the larger population, where the descriptive statistics take that set of data and just give you information about just that set. So descriptive, analyze the data to help describe, show, summarize it in a meaningful way. You look for patterns, answer the question, what does the data look like? Does not allow us to make conclusions beyond the data we have or regarding any claims. So it only deals with a sample, does not try to extend to a larger population. The types, once again, measures of central tendency, your mean, median, mode, measures of spread, range, quartiles, variance, standard deviation. And we'll get into those in more detail later on. But so for the inferential, does allow us to use samples to make generalizations or guesses about the population. And this is important because you can't measure every person in a population normally. So for example, if we wanted to know about Richland students, it would be really difficult to get a survey response from every single student at Richland. There's well over 2,000 students per semester who go to Richland, and trying to get every single one of them to answer a survey is be pretty close to impossible. So instead, what we would do would be to take a sample of Richland students and then try to make generalizations or guesses about the whole population based on the responses of that sample of students. So inferential does allow us to test statistical claims, which we'll do a lot with here coming up. It also, though, includes error and uncertainty. And why is that? It's because we're estimating values from a sample to the larger population. So since we aren't asking every single Richland student, like, what do they think about the bookstore, we only are taking a sample of students. That means we don't know for sure if every student really feels that way. We're only guessing or estimating how students feel based on the population that we have. So hopefully that makes sense, descriptive inferential. Moving along, so still talking about data, so sets of numbers, there's two types of data, categorical and numeral. And we will refer back to this again and again throughout the semester. So please make sure this makes sense or talk to me so I can help you make this make sense, because you need to know the difference. Categorical is qualitative, and qualitative just basically means no numbers. It means it uses labels, categories, not numbers. It would not make sense to add, subtract, or average categorical data. It could use counts or percents. So you could count something, or you could do a percent of something, but you couldn't add, subtract, or average it and have it really make any sense. So examples of this, t-shirt size, small, medium, large. So think about it. You wouldn't say, well, I'm going to take a large minus a small equals a medium. Well, no, there's really not probably an equal amount between a large and a small that would be a medium. Brands of candy. You can't say, well, I'm going to take a Hershey's minus a Snickers. Well, what does that even mean, right? But you could say that out of all the candy listed in the vending machine, 50% have chocolate, or 65% have chocolate. So that 65% represents technically a number, but it's a categorical number. It's not a number that you could technically add, subtract, or that type of thing and have it make sense. So that's categorical. Numeral is quantitative. Quantitative means numbers. So it actually uses numbers and actual quantities. In this case, it would make sense to add, subtract, or average this type of data. It would use some type of measurement and also often includes units like feet, minutes, pounds, that type of thing. To summarize a numeral variable with descriptive statistics. So these descriptive statistics up here that we talked about, you would use those descriptive statistics for numeral data. You would not use them for categorical data. So descriptive, numeral, descriptive, not for categorical. So moving right along. Now we're going to talk about levels of measurement. This is still in relation to data, but within the data, you can categorize the levels of the measurement, so what it's actually measuring based on these 4 different things. So the first one is nominal. Data can only be described with a name. So no order or value to the names. It's qualitative data. So colors, people's names, area codes. So just a name, no order. It would be like the types of candy bars. So because of that, if you go up here, that is also categorical data. Ordinal data adds order to the values. So you can't add or subtract the values. It is qualitative, but there is an order. So this is where your t-shirt size, small, medium, large, grades in a class, A, B, C, D, F, positions in a race, first, second, third. But similar to up here with the categorical, it's still using labels or categories. It's not actually using numbers. You couldn't actually subtract what's first minus the second. That doesn't make sense, right? You can't, once again, do a large minus a small. So interval, you can subtract the numbers and get a meaningful difference. So if you can subtract the numbers, that means we're dealing with numeral data. So interval data is often also numeral data. So there is no natural zero, so you can dividing of the variable values. You've got quantitative data, so once again, quantitative, numeral. Examples are temperature and standardized exam scores. The thing, especially with temperature, is that with the interval data, you can have negative. So you can have a negative there. So that's kind of the big thing. So think temperature, you can have it be, negative 10 degrees or something. So ratio has a natural zero that you can't be less than, which allows for the dividing. So no dividing here, you can divide here. So a person's height, you can't have negative height. Someone might be really, really short, but they're still not negative 3 foot or negative 1 foot. You can't be negative weight. You can lose weight, so I can say, hey, I lost 3 pounds, but I can't say, hey, my baby was born weighing negative 2 pounds. There is no negative there. So also number of people in a class, I can't have negative students in my class. Hopefully, in fact, you guys are all positive students. Negative money. Now, granted, you can maybe at your bank be in the hole by, a certain amount, but technically you can't have a negative amount of money. But that's ratio. Ratio is numeral data. So looking at our flow chart, and this might help you. So can the data categories be arranged in a measurable order? If yes, then you would come here, but if not, your data is nominal. If you said yes, they can be arranged in a measurable order, you then would ask, do the difference in the data categories mean anything? If the differences don't mean anything, so think t-shirt sizes, then no, your data is ordinal. If it's yes, you then ask, can the data categories be negative? So remember, negative would be like temperature. If so, your data is interval. If not, your data is ratio. So that's just kind of a handy flow chart to kind of help you work through it and help you better understand it. So moving along, types of sampling. So you remember when I talked about the example with, let's say we were interested in what Richland students think about the bookstore, right? And so we couldn't get a sample, we couldn't get a response from every single Richland student, so we took a sample, right? So types of sampling has to do with how did we decide or how did we pick which students we sampled from. So a simple random, aka a random sample, every item and every subgroup has an equal chance of being selected. This is normally considered the best sampling technique, but it can be difficult to do because you have to have a list of the entire population. So we could write the name of every student attending Richland on a slip of paper, put them in a hat, then have someone, without looking, draw the names of 50 people and ask those people your survey question. So there is a random sample. Another example is systematic. So when you go through and sample from every X number of things, that could be people, items, whatever. So in this case, we would have our list of every Richland student, and we would take every 100th name from an alphabetical list of all students at Richland and ask them our survey questions. Convenient sample is that's when we just use the people or items or things that are easily available to you. So there's no randomness, the results are normally not that good. However, it's easy and convenient to do this type of sample. So example, you just ask the students in one of your classes at Richland your survey questions. So see how these were randomizing who gets asked to try to make it more generalizable, because the more random it is, the more likely the results are to generalize to the larger population. Where for the convenience, there's no randomness. So no real generalization because it's not really random. We're just picking whoever happens to be convenient. Cluster is when the population is broken down into groups based on location, and then certain locations are picked at random, and everyone at that location is surveyed. So for example here, different classrooms at Richland would be considered locations. Then maybe 5 different classrooms are randomly picked, so 5 different locations would be picked, and all students taking a class in those classrooms or those locations are asked the survey questions. So that would be cluster sampling, and that is technically random. Another one is stratified, and that's where the population is broken into groups based on some characteristic or demographic, and then the sample tries to match the population. So in this case, the Richland student population consists of 61% females and 39% males. That's not true. I know that the numbers are out there, but I'll just be truthful. I didn't look it up. I just made this up. So to match these proportions, we would ask 61 women and 39 men our survey questions. And hopefully we would be random in picking our 61 women and our 39 men. So there are our different types of sampling. You will need to know about these types of sampling and how to do this and the pros and cons of these coming up in some of our group projects. So this is important stuff. How is our data collected? First of all, we've got observational or experiment. Now, I will fully admit there are different layers of this. There's different types of these. We're just kind of doing some big overreaching observational. The researcher does not manipulate anything in the environment. The researcher just studies, does not alter or control what happens. Data is gathered by making inferences of what is being observed. So does exercise prevent colds? You'd select a sample of subjects and record the amount of exercise and the number of colds that people got this year. So we would not ask them to exercise more. We would not do anything other than just say, go about your daily routine and just tell me how much exercise you did and how many colds you got this year. An experiment is where the researcher manipulates something in the environment. The researcher would intervene to change something and then observe and measure what happens. It normally involves a treatment group, which is experimented on, and a control, not experimented on group. So for our does exercise prevent colds, we would select a sample of subjects and randomly assign the participants to the treatment, exercise group, and control, no exercise group. After a set amount of time, we would record the amount of exercise and the number of colds for each person. So here we actually would have manipulated something. So there you go. There's kind of, I guess you'd say, the bulk of chapter 1 and what you need to know in, about 13.5 minutes. So if you have questions, please let me know. Otherwise, I hope this helped.